Let's try to solve another Leetcode problem, 131, palindrome partitioning. So we are giving a string S. We need to partition S such that every substring of the partition is a palindrome. And we need to understand what is a palindrome. So for example, AA is a palindrome, B is a palindrome. Yeah. And we need to return all the possible palindrome partition of S. So as you can see the result, this is AAB and here is AAB. Each of them gonna be a palindrome. And if we combine them together, it's gonna be AAB. And also for this partition, it's gonna be partition from here, AA. So AA is a palindrome, B is a palindrome. So that will only be the possible cases. So we're gonna return this kind of array. Yeah. So for the second case, we only get this A. Yeah, so this is a palindrome. As you can see, the length of the string is maximum 16, and S contains only lowercase English letters. So for this problem, if the length of the string is really small, maybe we're gonna use some backtracking. Yeah, if we think about backtracking, so what backtracking can help us to solve the problem? Backtracking can help us to solve the splitting a string. Yeah. So for example, if we have a string like this, if we have a string like AAB, what is the use of the backtracking? So the backtracking can always help us to split the string like this, AAB, or AA with B. Yeah. Or it can help us to split it as AA and B. Yeah, or it can help us to split it as AAB. We didn't split it. We keep it as it is, like this result A. Yeah. So there will be 4 different cases. Yeah, definitely we're gonna use the backtracking to have these 4 different cases, and then we need to check which case is valid. So this is not valid, and this is valid, and this is valid, and this is not valid. So we're only gonna return and get the valid case. So those 2 cases is what we need to get. Yeah. So this is how we approach the problem. And while we are using the backtracking, we need to find a way how to get the valid result. So for such cases, we will try to exclude it. Yeah. Now let's just try to write the backtracking function. So yeah, for the backtrack, so inside what it's gonna be, I'm gonna start from the index and I'm gonna have answer maybe. Yeah, I'm not sure. Yeah. So for the backtracking, I'm gonna call the backtracking, and I'm gonna prepare a result array because I want to put it inside a result array. After that, I'm gonna return this result array. So yeah, for the backtracking, I'm gonna start from the index 0 to check it one by one. So if there is a valid case, so for example, if there is a case like this, like AAB as my answer, I'm gonna put it inside of the result. So when do I need to put it inside of the result? I need to use this index. So if this index index equals to n, it means it goes out of the range because the length of the string is n. Yeah. So this means I also need to use a variable n. It's gonna be the length of the string. Yeah. So if this I equals to n, I'm gonna put the answer inside my result. Currently, I don't know how can I get the answer, but basically I gonna write it like this. Yeah. Now I'm gonna find a way to find an answer like this. Yeah, basically this answer will be something like like an array, and inside it's gonna be like A and B, or AA and B. Yeah, I will get such answers, but how can I get this kind of answers? So yeah, but anyway, let's just start the backtracking. So we're gonna start the backtracking. But before that, we don't know at which place we're gonna split it. Yeah, I'm not sure, but let's just use a for loop. So for j in range I, so I'm gonna start from the same index. For example, if I is 0, j is also starting from 0, And what is at the end? The end is n. That is the length of the string. Yeah. Now I can start backtracking. Yeah. So my index would be on z plus 1. Yeah, this is because if I choose index 0, it means I'm going to choose this letter A. Yeah, I only choose this letter A because index is 0. So it's going to be z plus 1. So for example, if I maybe 1, yeah, it means I choose a substring of AA. So my next string going to start in from B. So this is why I use the z plus 1. Yeah. And then it's going to be difficult, because from here I'm going to get the answer. So actually the answer is an empty array from the beginning. So it's going to be the answer plus a substring. Yeah. So this substring is going to be S starting from I and to z plus 1. Yeah. So let's just try an example. If we choose a letter A, so it means I equal to 0. And here S is starting from 0 to J. Z also equal to 0. It means Z should plus 1. Otherwise, I get nothing. I need to at least have one character because I cannot have empty characters inside my subarray. So I think this is enough. But this is for up to here. I didn't consider the invalid case. But let's just have a check. What is the result? Let's just check if the backtracking function is right or wrong. Let's just have a check. Yeah, concatenate list with a string, because this is a string. I need to concatenate a list. Yeah, now let's try this. Yeah, now let's check the result. It seems you can see the result. It seems it is okay. This is as I expected, because I want to get all the possible cases. This is valid, and this is invalid, and this AAB is valid, and this is invalid. I just need to take the invalid cases out. Yeah, this one and this one. Yeah, because for the second example, I only have one A, so it should always be valid. Yeah, but for the first one, this is not valid, and this is not valid. Yeah, so this means I need a validation check. So it means if I were to, if I were to append this answer, and this answer should always be valid. Yeah. So if this answer is invalid, I can stop the backtracking immediately because I will not return it. So from here, I can have a validation check. So if answer exists and answers -1 is invalid. Yeah. So I'm gonna write a valid function to check if it is valid or invalid. If the answer exists and not invalid. Yeah, with this answer -1. If it is not valid, so I'm gonna return immediately because I don't want to check this one and put it out. Because, yeah, for example, if I find one, it is invalid. For example, A is okay, I put it inside, and then I find AB, it is invalid. I will stop it immediately. I will not put it inside. So for this one, I find it invalid, I will stop it immediately. Yeah, I think this is a quick way to check, because basically, after find all the combinations, I don't want to check one by one. I just want to check from here inside the backtracking function, and it's going to be really fast. Yeah. Now we are going to write a valid function. So the valid function, I think it should be easy. Inside it's just a string, and we're gonna return this. Yeah, maybe I need to use another variable. Yeah, let me use another variable. Maybe result. Yeah. So the result should be equal to reverse of the string. Yeah. If it is okay, so this is valid. So if it is not valid, I'm gonna have a return immediately. Now let me run it. Now as you can see, it works. Yeah. Why it works? Because I don't need to check many of them. If I find one, so for example, I put I put everything inside the answers array. If there's a valid, I'm gonna stop it immediately. I don't need to put it inside anymore. Yeah. So this is why I will check it immediately from here. And if I were to check it, the answer must exist. So this is why I need to check if answer exists and not valid for the last word, yeah, or last string inside the answers array. I'm gonna return it. Yeah, it means it is invalid. Yeah. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and it's pretty fast. Yeah, maybe let's first analyze a little bit about the time complexity. Normally for backtracking, I didn't analyze. I always forget about it. So for analyzing the time complexity, so here is a for loop. So this will be n time, and for each one, we're gonna have an opportunity to split it or not, because at each place we can have a decision to choose to split or not. So it's gonna be n times 2 to the power of n. So n is 16. Thank you for watching. See you next time.